Hi, Scott and Darryl from Banner. Our module right now is going to be talking about how we apply all of these different sensors. There's lots of different approaches, different applications, a lot of different modes that we can operate in. Darryl, can you kind of go through the different modes that we have available in photoelectric sensing, how we may use those?
Sure, Scott, thanks. So Banner, we manufacture a lot of sensors. So you may be wondering, well, how do you select the right sensor for the right application? You start off by having to understand the modes. So we'll cover that a little bit. So we're going to start off with the oppose mode. The oppose mode consists of an emitter, which is in a separate housing, from the receiver, which is also in its own housing. Why we start with the oppose mode is because it offers the most excess gain. I'll get into excess gain a little bit later, but in general, excess gain is the amount of light energy a sensor gives off. More is better. So you typically want to start with the oppose mode. And the way it works is when an object comes in between the emitter and the receiver, it changes the output on the receiver. The next mode is retro or retroreflective. You have the emitter and the receiver now in one housing, but you have another object that is called a reflector. So the reflector shines at the emitter and receiver element, and when an object comes in between them, it changes the output on the receiver. This offers the second most amount of excess gain. From there, we go to the proximity modes, and we're going to start off with diffuse. Diffuse, once again, is a single housing the emitter and receiver. This simply spreads light out in all directions, and a target that is out in the distance will send that light back to the sensor, turning on the receiver's output. In that mode of diffuse, we also have a special variation of that called fixed field. The advantage there is fixed field, as its name implies, it will only see out to a fixed distance. What that gives us is the ability to ignore backgrounds. In the real-world applications in factories, you may need to detect a target, but there may be a shiny bracket or a shiny wall directly behind it. Fixed field sensors can ignore that object directly behind it. And similar to that, we have adjustable field. So now the distance isn't fixed. It's adjustable. We can move it in and out, and obviously that gives us some other advantages. So that pretty much wraps up the mode, Scott.
So depending upon if you have a clean environment, a dirty environment, whether or not you just need to know if something is there or not, or maybe perhaps have to figure out if that's at a specific distance away from the sensor, that's really going to help us determine what mode that we're going to want to sense in.